Exercise 8.2 question number 5. It is like this: ABCD is a parallelogram. E is midpoint of AB, F is midpoint of DC, and you are asked to prove that this point of intersection P and Q is trisecting the diagonal BD. Trisecting means it is dividing into three equal parts. P and Q dividing BD into three equal parts. That means BQ equal to QP equal to PD. That we are asked to prove. We are asked to prove this equal to this equal to this. Now, what is given? Given ABCD is a parallelogram. E and F are midpoints of sides AB and DC respectively. That is we have written, and you are asked to prove. What we are asked to prove? To prove this P and Q trisects BD. Trisects BD, that is we are asked to prove BQ equal to QP equal to PD. That we are asked to prove. Now proof. So first we will prove that this quadrilateral AECF is a parallelogram. We can easily prove that is a parallelogram. First step. See, AE is half of AB. We can prove we can write AE is equal to half of AB. What is the reason? The reason is E is midpoint of AB. E is midpoint of AB, so AE equal to EB. That means AE is half of AB. The reason is E is midpoint of side AB. Similarly, FC is half of DC. FC is half of DC. Same reason, F is midpoint of DC. So from here I can mark this equation once. Now AB is equal to DC, but AB is equal to DC. What is the reason? They are opposite sides of parallelogram. The opposite sides of parallelogram. So AB is equal to DC. So if I multiply by 1 by 2, half of AB is half of DC. Multiply by 1 by 2. Half of AB is half of DC. Why multiplying 1 by 2? I want to make use of this. So from here what we will get? You see, half of AB is AE and half of DC is FC. That means in this quadrilateral, you see AEFC, AECF, we already got opposite sides, AE equal to FC. But and also we have AE is parallel to FC. AE is parallel to FC. What is the reason? AE is parallel to FC. The reason is AB parallel DC. AB parallel DC, because they are opposite sides of parallelogram. If AB parallel DC, obviously AE parallel FC, because they are the same line. AE and AB are the same line. FC and DC are the same line, so they are parallel. So from this to what we are getting? We are getting AE parallel FC and also AE equal to FC. So AECF is a parallelogram. Therefore, quadrilateral AECF is a parallelogram, because one pair of opposite sides, that is AE and FC, are equal and also parallel. So we have proved it is a parallelogram. Now we will consider, we will take this triangle ABP. In triangle ABP, E is midpoint of AB. E is midpoint of AB, it is given. E is midpoint of AB, it is given. And also EQ is parallel to AP. EQ is parallel to AP. EQ parallel AP. How? Because EC parallel AF, since EC parallel AF, they are opposite sides of parallelogram. So if EC parallel AF, then EQ parallel AP. So what we are getting, you see, in this triangle you are getting E is midpoint of AB and EQ parallel AP. So Q must be midpoint of PB. Therefore, Q must be midpoint of Q is midpoint of PB. How it is? It is by converse of midpoint theorem. You will mention here by converse of midpoint theorem. So if Q is midpoint of PB, this implies BQ equal to QP. BQ is equal to QP. I will mark it say equation 2. Again we can take this triangle DCQ. Again in triangle DCQ, this triangle we will again apply here converse of BPT. In this triangle DCQ, what we have? F is midpoint of DC. F is midpoint of DC. It is given. F is midpoint of DC. It is given. And FP is parallel CQ. FP parallel CQ. How? Because CE, FA parallel CE. You can mention here FA parallel CE. They are opposite sides of parallelogram. So this same line, they are parallel. So what we are getting in this triangle? You see, we are getting F is midpoints of DC and FP is parallel CQ. So QP must be midpoint of DC by converse of BPT. P must be midpoint of DQ. Therefore, P is midpoint of what? DQ. By what? By converse of midpoint theorem. So what we are getting? You see, we can mark this. Therefore, P is midpoint of DQ. P is midpoint of DQ. That means PQ equal to PD. PQ is equal to PD. I can mark it equation 3. Now you see from 2 and 3 what you are getting? 2 and 3. From 2 and 3 what you are getting from 2 and 3? You see, you got BQ equal to QP and again QP equal to PD. So all the three sectors, all the three sections are equal. Therefore, BQ is equal to QP is equal to PD, and that is the complete proof.